Hello, hello. Yeah. Testing.
Estamos a tentar como a Miguel,
Hello, good morning.
mas estavam a aparecer as opções de...
Can you hear us?
Agora fizemos refresh e acho que já funcionou.
Yes, we can.
Okay, nice.
Tchau, tchau.
I see two friends there.
Está aqui, era aqui, admito os outros.
Buongiorno, Stefano.
Contributors... Não, isso sou eu.
The Italian connection here.
Este é o senhor?
Para baixo. Aqui para baixo tem mais gente.
Não tem, não.
És de Santa Gata e Jorge Alarcon. Ah, o de Jorge não está.
You have to put the mic.
Sim, mas não...
Não.
Este Ahmed.
Yes, Ahmed. Ahmed is also joining.
Yes, Hossein, Ahmed, and Ezio.
Hossein is not
Hossein,
here on the, it's not on the list.
I told him 9:15, so he should
Okay.
be.
But we have only two persons in this
Yeah, Hossein. Yeah,
this Mr. Ezio from Italy, I think,
correct.
and we are on the meeting. There are only two persons on the meeting now. The other persons have to join.
Yeah, he will join. He will join in.
The link they have sent it.
The presentation is already to be played here for MESAT.
He's going to make a presentation online.
Correct. It's only 5 introduction to the session. He's going to help with the introduction. He has 5 or 6 slides. He sent it already to Ricardo. If you don't have it, I have it. Stefan. Hossein Bahia. He will be the first one to speak for a few minutes. Oh, now we can see here. That's good. Morning.
Someone wants to join us.
Okay, now we can see.
Getting complex.
Yeah, it's okay. We'll get it done. Hossein?
Because it's not showing anything.
I thought he emailed, or let's see. Can I see the list? Can
Yeah, because Ezio, when he asked to the option to
you want me to come there? Let's see.
now it's showing up.
Hossein?
Fatih?
Yes,
Come va Stefano?
Ah, tutto bene. Speravo di vederla qua, prof.
Speravo anch'io, purtroppo è sfumata all'ultimo per questioni autorizzative.
Lei è in Qatar, no?
Sì, sono in Qatar.
Magari faccio un salto prossimamente, tanto un'ora di volo.
Ma infatti, perché lei, adesso io non avevo più notizie, perché in genere mi aggiornava Michele. Lei adesso dove è? Abu Dhabi?
Sono a Ras Al Khaimah,
Ah, ho capito. Ed è con?
un fornitore di bitumi modificati.
Ah, ok.
Quindi
Bene.
mi sono spostato nell'industria al momento.
Bello. No, allora ci dobbiamo vedere, perché sicuramente abbiamo, non solo per Chrome Rubber, ma abbiamo sicuramente da parlare tante cose.
Sì, volentieri, possiamo organizzarci per un meeting. Può venire lei in azienda da noi,
sì.
possiamo venire noi in Qatar.
Volentieri. Voi al venerdì lavorate?
Venerdì sì, venerdì e sabato mattina anche. Quindi.
Beh, cioè dico bene, ma perché per me il venerdì è un buon giorno per viaggiare qua in the region, perché da noi è weekend,
Ok.
però ecco, so che per esempio negli Emirati ormai il venerdì è lavorativo sempre, per quasi tutti.
Sì, sì, noi venerdì abbiamo giornata piena e sabato mezza giornata, quindi possiamo organizzarci di venerdì. Volendo.
Fantastico. Io avevo sue notizie da Michele, poi a un certo punto con Michele, è peggio di me Michele, è difficile sentirlo, quindi Michelino. E niente, dai, ma io sono qua ormai da un bel po', come lei. Io fisso qua sono dall'inizio del 2023,
No.
con Qatar University dal gennaio 23.
Ah, quindi...
E vabbè, qua ci stiamo facendo i cavoli nostri, ma tanto c'è da aspettare, quindi va bene.
Ah, sì, è un pochino in ritardo qua.
Sì, ma non c'è problema, non c'è problema. No, io sono qua da gennaio 23, però on and off dal 2017, quindi ormai
Ah, beh,
un bel po'.
parecchio tempo.
Mi ricorda in che anno si è laureato lei?
2018.
If he doesn't join, I can maybe.
Era quando avevo cominciato a viaggiare sul Qatar. E vabbè, dai, tante cose da dirci.
Sì, ci
Poi
vediamo
magari
presto.
ci sentiamo via messaggio. Lei mi mandi una email, così poi ci scambiamo anche i numeri di telefono e ci possiamo sentire via WhatsApp.
Perfetto, le scrivo nel pomeriggio finito qua.
Mi può scrivere o sulla email del Poli o su quella di Qatar University, è lo stesso.
Ok, benissimo.
Va bene?
La ringrazio.
Poi chiacchieriamo un altro momento. Camila, I was taking the opportunity with Stefano just to have some conversation.
To coordinate?
No, just some conversation, because Stefano was my student, and I haven't been seeing him for a long time.
That's great. Okay.
He was my student in Torino.
Fantastic.
So-
So we will have little time. We are running a little bit late, but we'll have little time for discussion at the end if that works. We'll see.
Yeah, I'm available. Of course,
you.
our discussion now was not technical. We were just kind of chatting, the Italian thing.
We are here and both Prof. Santagat and
Hossein.
him are
Okay.
online.
Did he join?
Are you able to join? I will give me. Okay. I'll give the phone to Prof. Kalush, so we can coordinate with him.
Hossein, what's up? Yeah, it was sent after. Ezio, can you send the latest link to Hossein since you are online there?
Sure.
Okay, he's going to send it to you right now.
Yeah. Just 1 second.
Yeah, okay, so that explains things. Okay, we'll start in a couple of minutes then. All right, thank you. Yeah, he had the previous link.
Did he find it, or do I need to send it?
No, go ahead, please send it. Because he
Yeah.
sounded like he's in the other one. Yep. He's connected? No. Yeah, just give him a minute, I think, yeah.
I sent him the link. So.
Thank you.
You want to start the presentation?
So Hossein, I think, yeah, we can, but I'll wait for him to join to just welcome everybody and. So we can put this in full mode if you want. We can put this in full screen.
No, because I'm going to put full screen the
Speakers.
Stefan
Okay.
online and the presentation.
Okay.
RAR.
Hey, we are almost there. That's good.
Everybody's in the room.
Did Hussein join?
Yes, I did.
Okay,
Can you hear me?
fantastic.
And we're going to share.
Can you hear me?
Yes, we can.
Yes, we can.
Can you see me though? You probably cannot see me.
We cannot see you, but we can see the presentation.
All right, that's more important than me, so.
That's
The
okay.
presentation is showing that now.
Okay.
Hello, everyone.
Everybody sing on the screen and presentation.
Fantastic, fantastic. Yep. Bon dia, good morning. Buongiorno, we have Italian, and bonjour in French, and we have a couple of Arabic speakers. Sabah al khair. So welcome to this MESAT session for the Middle East Society for Asphalt Technology. We have three exciting speakers this morning to participate and talk about the crumb rubber use in the Middle East. So to talk a little bit about MESAT, just for a couple minutes, we have Professor Hussein Bahia, Professor Emeritus from University of Wisconsin at Madison. He will present a couple slides on what MESAT is all about. Dr. Bahia, you have the floor.
Thank you, Dr. Kaloush. I really appreciate the opportunity to talk just a couple of minutes about the MESAT organization. I'm presenting on behalf of the board of MESAT. This includes a couple of very good colleagues, Professor Nader Tabatabai from Sharif University. And by the way, we do have a website hosted by Sharif University. Also, Professor Nariman Khalil, she used to work at the University of Balamand, and of course, Dr. Kamil Kulash. Next, please. I don't know who's controlling this. Great, very good. So we can skip this. I'll go directly to talk about MESAT. MESAT is an organization that is more than 15 years old. This started by a few academics from the Middle East as well as from the US. It's an association of academics, practitioners, and managers of asphalt roads. We do try to serve as a technical forum. We don't produce anything, but we try to share knowledge. So we try to connect people that are interested in this field to really improve our knowledge collectively and to understand what are the challenges in the region. We try to develop effective methods for delivery and maintenance of asphalt roads in the Middle East, and perhaps in the future we'll expand it to more than the asphalt roads. We do have close relationship with many organizations that most of you probably belong to or you work on. So let's go to the next slide, please. Our objectives are very simple. It's to foster sharing of scientific and engineering knowledge. And I would like to really acknowledge all the effort from Dr. Kamil Kulash in integrating MESAT session into the rubber asphalt conference in Portugal. So thank you, Dr. Kamil. We do coordinate conferences and webinars occasionally when we see that there is an opportunity for that, and we do try to solicit sponsorship so that universities or organizations host the next MESAT. We try to do it once every 2 to 3 years, and we are due to give a conference. So hopefully some of you will be interested and contact Camille or myself to really try to organize the next conference for MESAT. We try to bridge the gap between research and practice. We're not academician trying to only develop research. We try to bridge the gap between research and practice, and hopefully the lectures today or the presentations will show you what we're trying to do. We do communicate and share experiences with asphalt technology associations around the world. And let's go to the next slide. I think this will be my last slide, Camille. Here is a map of the Middle East. We welcome any really country that would like to join us, but we're focused on these countries that you can see in front of you. There is a number of countries that are very active in building roads, and therefore this sharing of knowledge is very important. Next, please. One of the things that you all know very well about asphalt, and that's why we use asphalt rubber, is this climate issue and the extreme temperatures that we see in this region of the Middle East. We do have very cold regions, but actually one of the main challenges is the high temperature, extreme high temperature that we see. And unfortunately, as most of you probably know, global warming is making this problem even more extreme. We see problems with asphalt roads because of the hot weather all over the Middle East, and hopefully your efforts and MISAT effort to coordinate conferences will try to mitigate some of these problems. Next, please. There are many specifications that are in the Middle East, and particularly in the last 10 years, since or after MISAT started, the propagation or the adaptation of the performance grading of asphalt binders or bitumen is becoming very common. We have a huge database on all the grades that are being used in the Middle East, and we'll be very happy to share this with you when and if you really need such information. Next, please, Camille. I have to tell you that this is a very good opportunity for us to present MISAT because asphalt rubber is a modified bitumen. I think that is very obvious from the name of it, and we're using a recycled material in many cases to improve it. Asphalt rubber has been used in warm climates in many regions, particularly in the US, and if you Google Professor Camille Kulash, the history of scholarly publications, you will see how much work he himself has done and his team on this topic. So there are many ways of modifying bitumen, but certainly asphalt rubber has proved to be one of the attractive and cost-effective methods. So I wish you a very good session. I'm sorry I'm not there in person, but I'm very eager to listen to the expert that agreed graciously to really help us with this session. Thank you, Camille, and turn it back to you.
Thank you, Dr. Bahia. This is a great background. I also should have mentioned that Dr. Bahia, one of the co-founders of this great organization for the Middle East. We appreciate all that you do. So our first speaker here in this session is he does not need to be introduced. First time I met Professor Ezio Satagata was back in 2000. It's been almost 25 years, Ezio, in Italy. So he has been doing a lot of pioneering work in the asphalt pavements and lately, of course, in the crumb rubber applications. So he's currently a professor at Qatar University. And as you feel free to introduce yourself and what you are doing in Qatar, and you have the floor for the first presentation.
Thank you so much. I will share my screen, first of all. Can you see my screen now?
Yes, we can. Everybody's good? Yep.
Okay. So thank you, Camille, for the very nice introduction. Too kind of you. And thank you to the organizers of this conference and of this specific session of MISAT. As Professor Kaloush was mentioning, I am currently serving as a professor of civil engineering in Qatar University, and I will be bringing you my experience and view on the current situation in the region based on what has been going on in Qatar. So this is the outline of my presentation. I will start with a brief introduction about myself and of the recycling in pavements in the region. Then I will go to the lessons learned in Qatar through the so-called Ashkal Recycling Initiative, and I will close with an outline of the current challenges in Qatar and some final thoughts. So for the self-introduction, this is not really the right place to give you my CV, but I wanted to explain why I'm talking about Qatar. I'm clearly Italian, and I've had my academic and professional career in Italy since 1994. However, I've been interested in the opportunities and challenges in the region since 2014 through a study tour that included Qatar, the UAE, and Oman. And since then, I have been more and more involved. The how can I say, the core of the activities was carried out in the period between 2017 and 2021, when I was in Qatar with the ANAS team as the technical director of the QA/QC project. And the focus was on the Ashkel Recycling Initiative. By the way, this project was previously guided by Professor Bahia, which left a lot of work, fantastic work done. And for me, it was really smooth to take over. I've been a member of board of directors of MISAT since 2018. And more recently, in January 2023, I've joined Qatar University as professor of civil engineering and Ashkel chair. Now, to be an Ashkel chair really involves some responsibility with real projects. Ashkel is the Public Works Authority, so the focus of my engagement in the university and with the Public Works Authority, Ashkel, is to enhance the use of recycled materials in infrastructure projects. And of course, crumb rubber is one of them. So in the region, I've done some work on recycled materials. The research approach I've been adopting, which it's actually the same I've been adopting in Italy for some time, and I believe it is particularly suited for this region, is to take into account some pillars. First of all, when recycling, we should avoid the substitute and add approach. The road is not a landfill, and we need to approach it differently. We need to use fundamental concepts, multidisciplinary know-how, some diagonal thinking. Of course, we need to focus on end performance and try to create through recycling an added value. Research is expected to be at least at the pre-industrial implementations level, and it should include the quantification of economic and sustainability factors. And finally, there should be the attempt to promote activities which are both of the top to bottom and bottom to top project. What I mean is that we may have requests from the industry and we will execute these research, or we should try to push for our own ideas in order to be accepted by the industry. And of course, at the end of the day, we need to disseminate. So there's been several success stories, including that of crumb rubber in the region. Now, a few more slides on the general situation. What is really promoting sustainability, recycling here in the region, at least in Qatar? Well, the first component is sustainability, self-sufficiency, and innovation. Self-sufficiency has been, in fact, put at the center of the stage because of the political situation in 2017, but it was also seen as an opportunity in order to push for sustainability and innovation. And of course, there are some guidelines coming from the United Nations, as well as generally shared circular economy concepts that have contributed to corroborate and make this kind of inclination more robust. Likewise, there is a need for premium performance in extreme conditions because of high temperatures, heavy loading. So there is the need for alternative and high quality components, and recycling can be one of the options, and including, of course, crumb rubber. So with that said, I'll go to the lessons learned in Qatar through the Ashkel Recycling Initiative. I'm sorry if I'm speaking very quickly, but I will try to give you a very quick overview of my experience. And I believe I need to stay in the 15 minutes. So in Qatar, there has been a very strong support from the government and an overall plan. So back in 2017, Ashkel had a circular in which they promoted the use of recycling material. And all the departments were alerted to maximize the use of recycling material. This was something really new because in standard construction specifications, the so-called QCS, no recycling material was allowed. And even talking to the players of the industry, this was seen as something that was not acceptable. Now, the motto of Ashkel, maybe you can read it, it's very small here in the slide, is Qatar deserves the best. And according to this motto, in the years before 2017, for example, during my study tour in 2014, to talk about crumb rubber and pavements was totally unaccepted. Now, there was a change, 2017. And this was picked up by the general strategy of the country, the Qatar Strategy Sustainability document, in which it was explicitly stated. Now, I can read a little bit of Arabic, but I have translated it for you. The goal for 2022 is to use 20% recycled materials in projects. Very ambitious goal. As a result of that, the Ashkel Recycling Initiative was launched, And it was composed of different actions: identification of recyclable materials, selecting of recycling technologies, verification of local technological feasibility, the so-called field trials. This was a key step in the recycling initiative. We had to leap forward and go to the trials without having all the research done before that. And this was essential. If not, we would have lost the opportunity. Then, of course, there were several actions due to the enforcement of the decisions and the definition of strategic goals and the creation of a specific Qatari know-how and development of appropriate design tools to account for recycling. So many options for recycling back then. One of them, and this I need to talk about it, is chrome rubber. Okay, so clearly this was one of the several options, but it was clear from day one that it should be used as a bitumen modifier, as an alternative or supplement to SPS. My work on the use of chrome rubber in pavement started, let's say, in 2006, 2007. So I had some experience, some ideas, and I tried to give my contribution here in the country. And again, back then, there were some potential limitations. We're talking about 2017. In the case of chrome rubber, there was some concern related to the limited production capacity and to the cost efficiency that needed to be verified. Nevertheless, there was a strong drive for recycling in general and for chrome rubber. So activities proceeded. So we identified several possible sources of materials to be recycled. On the left, bottom left, you see here 2 dumping areas. We cannot call them really landfills. Dumping areas in which there were large quantities of tires, you can tell from the images, and many others with other potential recycling materials. So after that, we started the field trials. So this is an example. We had several. Basically, we referred to the mix designs that had been approved for PMB mixes, and we simply substituted the PMB with the chrome rubber modified bitumen. We know this is not exactly the way to do it, but okay, we had to, as I said, leap forward. The CRMB was of the terminal blend type, and approximately, of course, the contractors will not exactly tell you, around 11% by weight of chrome rubber. And it was graded as a PG 76V -10. In Qatar, the classical modified binder is a PG 76 -10. And the target binder content 3.9. We're talking about a wearing course. Please consider, I don't know if my European colleagues in the audience have some experience with this, but here in Qatar, mixes are extremely dry, very dense, an aggregate structure which is very compact, very low binder content. And of course, this prevents rotting. We have very, very rare cases of rotting in the country because we have thin asphalt layers and very dense with a limited bitumen content. Okay, but what happened in the trial? Okay, we went through all the analysis and the investigations. We found that the contractors were ready to produce. The binder content was acceptable. The grading analysis were fine. There were some issues with compaction. This is underlined because this is still today an issue. Not always, but it can be an issue, which can give some problems for performance. And then, of course, we focused on performance testing because we wanted to validate the potential performance of these mixes. So a very brief summary. We went through, of course, all the classical tests. On top of those that we could use from some modeling and analysis. For example, flexural stiffness at 7% void content at different temperatures. We compared a CRMB mixture with a PMB mixtures. And basically, you see it here in these charts. The stiffness was almost equivalent, and we also had very similar phase angle values. Okay, so we can say that there was a certain equivalency between the PMB mixture and the CRMB mixture. Back then, this was the focus to establish the equivalency. In terms of dynamic modulus at different temperatures and of course at different frequencies and with the consequent construction of master curves, we compared once again the two mixtures and we found that the CRMB mixtures showed higher stiffness and lower phase angle values at all frequencies and temperatures, and this difference increased at the very low frequencies. So definitely this was promising for with respect to the potential performance, and we were also meeting the QCS limitations for dynamic modulus, which in fact is quite low. In terms of rotting resistance and looking at the flow number, again, we observed a certain equivalency between the two mixes. And once again, we were respecting the QCS limits established for the super pave mixes containing PMBs. So we checked the box, of course, with several field trials. We concluded that, okay, the country was ready for this, but nevertheless, contractors and consultants needed some kind of guidance. So we worked on some guidelines for the pre-qualification of crumb rubber and crumb rubber modified binders, and guidelines for the mix design of corresponding asphalt mixes. And these guidelines were made official. They were enforced by Ashgal, and obviously the contractors had to take them into account. Now, all of this was embedded, as I said, in the Ashgal recycling initiative. It was made official in 2018 with its own roadmap that required a timeline of 18 months and several supporting actions which involve logistics, regulatory requirements, mix design, and support from the Quality and Safety Department. What is really important to underline is that we had yet another circular from Ashgal in which CRMBs were made mandatory for use in substitution of PMBs in all local roads projects. Now, this was a turning point. All local roads projects, and we're talking about basically all the pavement projects, excluding the expressways and the major arterial roads, had wearing courses, were required to have wearing courses with CRMB. So this made a difference. With respect to the acceptance requirements, the CRMBs, the binders, it was simply required that the PG grading was to be a 76-10 as per local need. So we were applying AASHTO M332 with the exception, of course, of the clause on viscosity. For the CRMB asphalt mixes, we had basically requirements referred to the classical Marshall mix design with some additional checkpoints related to the tensile strength ratio and the rut depth measured using the Hamburg wheel tracker tests. Additionally, we had other requirements that could be included in projects which refer to the dynamic modulus, to the flow number, and once again to the rut depth in order to have a better control of the potential performance. So supplementary performance testing was included as requested by the engineer. The system that was created in Qatar, and to be honest, this was the work that was previously done by the team led by Professor Hussein Bahia, entailed a very articulate procedure for quality assurance and quality control with the submission of mixed designs that were reviewed by the Quality Safety Department and plant trials that were verified experimentally by the Quality and Safety Department. So very tight control on the qualification of materials and contractors, their entire system. One step forward again, in 2021, we issued the Ashgal Recycling Manual. The authors are several. These come from the Ashgal and from the team, the ANAS team that was working in collaboration with Ashgal. And if any of you are interested in giving a look, you can just send me an email and I will send you a copy of this document. It includes crumb rubber and other materials. Of course, some supporting research was going on. Okay, we had the trials, but we were doing some research. These are some examples. We did a lot of rheological testing on CRMBs and the corresponding base neat bitumen, looking at how the master curves were changing with modification, both in terms of the complex modulus and of the phase angle. I cannot get into the details of this, but of course the database that we created was quite vast. It was coordinated by the Ashgal Center for Research and Development and the Politecnico di Torino, back then my university, did a lot of experimental work. We also worked on the chemical characterization of neat bitumen for the assessment of crumb rubber compatibility. And the main tool we used was the Yatroscan for SARA analysis. And we coded and classified the different sources of bitumen and related this to the compatibility with crumb rubber. And this was very useful for the formulation of stable CRMB binders. Current challenges, very briefly. The general observation is that the significant portion of projects with CRMB wearing courses are in acceptable conditions and exhibiting a performance which meets design expectations. However, in some projects, early cracking has been observed. And some time back, I've discussed this with Professor Bahia, and he has a lot of experience in the region. And we made some hypotheses of the possible root cause. Now, in fact, we are narrowing down the root cause analysis, and we are getting there. And more or less, we had the correct idea. But before getting there, many surveys had to be done, visual and with the laser crack measurement system. And we also recommended extensive field and laboratory testing in order to go through the appropriate analysis and model. Critical issues that have been identified according to the preliminary assessment are compaction and aging. We're not surprised, of course. With CRMB mixes, compaction can be a problem. This is related to the compaction temperature. Sometimes it is related to the fact that these materials are so dense that it is difficult to move the aggregate structure. And to be honest, contractors sometimes tend to overcook these mixes in order to have sufficiently high temperatures at the exit of the plant and when they are arriving at the project. But still, we do have some compaction. And aging, once again, it may be a result of this overcooking, as well as the effects here of the UV radiation. And we know that simulative aging for this region is not a trivial task. So as a result of that, we decided to get into deep of these compaction and aging issues. There are some ongoing research activities that are generated by the collaboration between Ashgal and Qatar University. We're doing a lot of work on the mixing and compaction temperatures, focusing on the Cazzola method, the NCHRP 648 protocol, the so-called phase angle method. Very simple, very popular. We are encountering a lot of issues, not with the method itself, but on how to implement it and how to involve independent laboratories to apply it correctly. And of course, the CRMB by itself poses some issues in the data processing and in the data measurement. The other tool we are using is an analog-inspired tool for the modeling of gyratory compaction, which allows us to extract workability and compactability parameters. This is a work that was previously developed in Politecnico di Torino by one of my PhD students, and of course we are developing further in order to apply it to the case of dry mixes and in the region with CRMB binders. And finally, we are working also on the development of alternative aging protocols that can be simulative for the region. Another activity which is currently running is with Qatar University with a private company of the US, the so-called IP crack project. The idea is to use a polymeric additive in order to enhance the construction and performance-related properties of CRMBs, in particular with a focus on workability and compactability. And we have structured the project at the molecular binder and mixture level, and we are expected to come up with a proposal for amendment of current specification. This project is Qatar University with this private company and with the collaboration of Professor Hussein Rehi. My final thoughts, very quickly. I can state, based on my experience and conversation and discussion with colleagues, that the use of chrome rubber in binders and mixtures in the state of Qatar has been overall positive. And nevertheless, as academics, we need to promote some research to move forward. We need to support government industry to understand the root cause of observed early failures. This is critical. If we don't do it properly, we will lose the opportunity to do more work and implementation with chrome rubber. Definitely, we need to enhance pavement performance. Chrome rubber, we know, has this potential. If we use it properly, not only we will not have defects, but we can enhance performance. And this is the right time to push for this. This may require development of new techniques, maybe new analysis approaches. Definitely, we need to support implementation with technological solutions, with an appropriate interaction with the industry. We need to think of updating specifications and standards. This can be also part of the game. We should not forget about including environmental impacts in future assessments. And finally, as academics, we need to remember that research is fun, but also dissemination and sharing is part of it. And we should give our contribution to the continuous advanced education of all involved players. I'm not only thinking of our students, I'm thinking of the players of the industry, which are eager to learn from us whenever we have something to teach, which is real. And with that, I thank you for listening. And in case you want to contact me, this is my email, ezio.santagata@qu.edu.qa. Okay, thanks.
Thank you, Ezio. We can take a couple questions. If you have a couple questions, you can come to the microphone here, make sure it's on, so they can hear you. And we do have some chocolate from yesterday still in the basket there by the mic, so that might be good incentive. The last slide, you have a question? You want to come up and, okay, just come up, it's fine. You can introduce yourself and make sure the mic is on, please. There's a button there, yep.
Just if you could show the last slide, I didn't get the email address.
Oh, he wants the email address, Ezio, if you don't mind showing the last slides.
Yeah.
Maybe take a photo.
Of course. Give me a second, I'm sure again.
Dr. Souza, George Souza, are the slides going to be online for?
Yeah.
Okay, on the website or something. Okay, that
There you
will
go.
help.
So take my email, and for any of my friends there in the meeting, and for people I don't know yet, of course, visit Qatar. It's very exciting.
We have a question. You probably can see, yep, Amir coming up.
This is Amir Kabusi from Iran. I'm actually pleased to inform you that we are a member of committee members of MISAT in Iran. Professor Bahia did not have time actually to explain more about the MISAT. MISAT has different committees in different countries. For example, in Iran, we are a big committee of the members of MISAT. I myself in a university where we are doing research. There are different universities and research places that we are in line with MISAT guidelines to do research. Me, myself, for example, had some 50 postgraduate students before. Therefore, we appreciate now also Professor Santagata to join in Qatar and to work with us. He is dedicated really to asphalt. Not only him, I studied in Italy, and his father was a professor of pavement engineering. So their generation is dedicated, we can say, to pavements. So my question was about the binder content that Professor Santagata told about. It was 3.9%. Was it for the conventional asphalt mix, or was it for the rubberized asphalt mix? Because if it is rubberized asphalt mix, one would expect to have much more binder contents, because, you know, if we want the rubber to be active, so it absorbs some components of the bitumen and so on. So if you can explain on that, I appreciate. Thank you very much.
Yeah, sure. So thanks, Amir, for your question and for your very kind words. Of course, you're a true friend, so you always take the opportunity to be kind with me, my family. And okay, we'll talk in Italian later. Ci sentiamo più tardi. So to answer your question, as I was mentioning, mixes in Qatar are dry, very low binder contents. So the acceptance range for mixes, let's take the case of wearing courses, is between 3.4 and 4.4%. Now, I agree, maybe for some types of binders, we would need to increase the range or to increase the target binder content. But in this country, I can tell you it's impossible. To move this, it's very difficult. There has been some bad experience in the past when trying to lay mixes with higher binder contents. and there is a state organization which is checking the mix designs, and it will be very, very difficult to change. So this is one further challenge for CRMBs. These are terminal blends, so let's say we believe they can be equivalent to PMBs. This is one further challenge to make it work, although we are trying to minimize the binder content. When that 3.9 included everything, it's the chrome rubber binding overall.
Okay. Thank you, Ezio.
You're welcome.
Anybody else? I do have, just so if you can provide a quick feedback, Ezio, just because of the time. I was kind of intrigued and concerned about this overcooking of the hot mix at the plant. We had similar experiences back in the state of Arizona. We had to do something about it because it can really drastically change the characteristics of the mix. Any thoughts on why, how that can be controlled, and if there is any measures being taking place, whether it's a crumb rubber mix or not?
Look, this has been observed. Now, from the, it has been observed, but let's say on an anecdotal basis. Now, what is currently happening through the Quality and Safety Department of Ashgal, and we are collaborating on this, is in one of our research projects, we are following the contractors at their plant, and we're taking samples of binders and mixtures at the different stages of production. Okay, so in order to see if there is some overcooking, to have some numbers about it. Now, why does this happen? The classical reason is that contractors are worried that if they don't increase the temperature sufficiently, they will not have a proper coating. And more than that, when the material will reach the construction site, which can be far away from the production plant, temperature will be low and compaction will be an issue. So this pushes them to overcook. Now, how to avoid this? Fortunately, the tools that can be enforced here in the country are very powerful. So the records from the production can be requested for any moment from any plant. And this very tight quality control system, as I said, was created by the ANAS team here in Qatar when it was led by Professor Bahia. Now we are building upon this great work and applying it to different types of materials. So to enforce it, okay, we need to check the construction records. On top of that, we are trying to provide some guidance on the choice of the correct mixing and compaction temperature, because suppliers of the CRMB binders, they are giving ranges. And we are trying to make this assessment of mixing and compaction temperature through the Cazzola method or any other method to be consistent, repeatable, and reliable. So we expect to have some improvements on that. And on top of that, I think that by using some smart solution, as that polymeric additive I was mentioning, can improve a lot of the issues that we have been facing, and perhaps the need for overcooking will not be that drastic. We know that overcooking is expensive, by the way, but energy in some countries is very costly, and some others a bit less.
Thank you very much. Thank you for your input. So with that, I think we'll move on to the second speaker. Thanks again, Dr. Santagata.
Nice seeing you guys, and thanks for inviting me once again.
Thank you. Big round of applause for you. Our next speaker, Stefano Marini. He's a senior technical service engineer with Elrich Bituminous Systems in the UAE. So, Stefano, the floor is yours for your presentation. And for those who joined us a little bit late, we had a late start, so hopefully we can catch up, but just keeping you in mind that we are on track with this program.
For those of us online, is it possible to share the screen for Stefano's presentation?
So yeah, we are sharing this presentation online as well. And we have a third presenter also will be joining us who's online for this session.
here or here?
Okay. Good morning, everyone. I'm Stefano Marini, Senior Technical Services Engineer for LRH Bituminous System in UAE, and today we'll give a brief presentation about the hybrid cramp rubber modified bitumen that we use for the Dubai Expo 2020 project. Okay, so just a brief introduction about our company. Our company is based in UAE. We have our terminal of 14,000 metric ton in Ras Al Khaimah, that is the northern emirate, and we work with everything related to bitumen, so polymer modified bitumen, emulsion, cutback, and cramp rubber modified bitumen. Our main area is Middle East, but we work a bit all over the world, and we have different contracting in India, and we can ship material everywhere, both in drums, ship, and bitutainer. So the project we will talk about today is the Dubai Expo in 2020. So from October 2021 to March 2022, Dubai hosted the event Expo 2020 with 1 year of delay due to COVID. And the event recorded more than 24 million visitors. And for this event, the RTA, so the Dubai Road and Transport Authority, built a car park with around 30,000 cars capability. Since one of the topics of Dubai Expo was sustainability, the RTA decided to use for the wearing course of the car park cramp rubber modified bitumen. And for the project, they decided to use a 50 millimeter thick wearing course, and our company supplied a total of 8,000 metric ton of hybrid cramp rubber. And these are the area paved with cramp rubber modified bitumen. Since there is no proper specification in UAE at that time about the cramp rubber, LRH cramp rubber is based on the requirement of ASTM D6114 and Arizona DOT, and it was manufactured using local cramp rubber from UAE and some proprietary additives. These additives were specially designed and selected to overcome some of the most common disadvantages of cramp rubber, like high viscosity and high compaction temperature. And since it was one of the first projects using cramp rubber in the region, the contractors were a bit scared about this new material, and that's why they asked us to design something with a bit lower viscosity, but still using cramp rubber. So as I said, our hybrid cramp rubber has a lower viscosity compared to normal rubber modified bitumen. It has a longer storage life, and we had to do this because the contractor was not sure about the immediate use of the material, so we were not able to produce cramp rubber and use it immediately. Sometimes the modified bitumen had to stay in storage for a couple of days, and we had to assure that the material will not degrade during this time. And other advantage on the mixes produced with our hybrid bitumen is a better workability, since the mixing and compaction temperatures are lower, higher rutting and cracking resistance compared to normal cramp rubber modified bitumen, and also higher resistance to moisture damage. These are some of the properties of hybrid cramp rubber that can be classified as a PG76-16, and how we can see here, the viscosity at 135 is relatively low compared to normal rubber modified bitumen. The mix design was performed by the contractor using a standard Marshall mix design method that is commonly used in UAE, and then verified at a governmental reference lab. And all the process was supervised by Parson consultant. Since it was one of the first time of using a Cram-Brabber modified bitumen in the region, there were no specification also for the mix, so the designer and the authority just specified air voids range. 3 different gradations were tested, but in the end, the authority decided to use a standard dense gradation that is commonly used in the area and a gradation that they are comfortable with. These are some of the pictures of during the trial. Another trial was done with a gap-graded mix that showed very good performance, good texture, but in the end it was rejected. These are some pictures with the dense-graded mix. And this is a comparison, of course, taken from both the gap-graded and the dense-graded mix. As expected, the gap-graded gradation had a much more evident texture compared to the dense graded, but the authority was a bit scared of using this new gradation, so they decided to go back to the standard dense graded mix. These are the results of the mix design. The optimum binder content was 4.9, that it was quite high for the region, where usually a dense grade mix has from 3.8 to 4% binder content. And these are some of the other properties from the Marshall mix design. Other than the standard mix design, it was decided to run some performance tests on the mix. First one was to verify 2 different rubber producers and using 2 different crushing methods. So it was tested a Cram-Brabber produced using a cryogenic method and one rubber produced using ambient temperature crushing. Mixes were prepared in UAE and then shipped to Wisconsin to Dr. Bahia lab, Modified Asphalt Research Center, and both rutting resistance using Hamburg wheel tracking test and the CT index were verified. This was done to verify if using cryogenic crushing method could lead to better properties of the mix, even if the cost of the raw material was a bit higher. These are some of the peculiarity of cryogenic process. So rubber produced using this method has a higher uniformity, a smaller dimension, and a lower specific surface, but it also has a lower productivity and higher cost. So it was decided to verify these 2 types of rubber to see if the advantages of using a cryogenic process can overcome the higher cost. Rutting resistance was tested using a Hamburg wheel tracking test at underwater at 50 degrees, and the rut depth at 15,000 passes and the stripping inflection point were measured for both the mixes. Both of them had good results, but cryogenic rubber showed better performance compared to the ambient temperature one. And this is the average graph of the two mixes. Cracking resistance was verified using ideal CT test at 25 degrees, and both the peak load and the CT index were measured. Both mix perform quite well, and also in this case, the cryogenic rubber showed better performances compared to ambient temperature crush rubber. Also, another test we ran, it was the war mix properties verification. This because, as Dr. Santagata said, sometimes there is the need to overheat the material because the contractor is scared about the compactability of the material on site. But one of the advantages of using hybrid Cram-Brabber modified bitumen is that the workability and the mixing and compaction temperature can be lower. To verify these performances, we shipped some material again to Mark Laboratory in Wisconsin, and samples were prepared using a gyratory compactor at 2 different temperatures, 165 degrees and 135 degrees, so 30 degrees lower than the conventional temperature. And then the ratio of the number of gyrations needed to reach 92% of the GMM were measured. In this case, the ratio obtained was 1.15, and that is lower than the AASHTO criteria of 1.25. That means that the material has a good compactability even when compacted at lower temperature than normal. And these are the compaction curve from the mixes at the two different temperatures. And this test highlights the good workability of mixes prepared using a hybrid Cramp-Brabber modified bitumen. So in conclusion, as we said, for this huge global event in Dubai in 2020, Cramp-Brabber modified bitumen was used to pave all the 30,000 car park prepared for the event, and LRH was selected as the Cramp-Brabber modified bitumen supplier. To overcome some of the common disadvantage of Cramp-Brabber, a special hybrid bitumen was developed, and the test and the mix was tested for its performances using both wheel tracker and city index test. Two different rubber were tested, and cryogenic crushed rubber showed better performance compared to ambient temperature crushed rubber, and the mix prepared using hybrid Cramp-Brabber show warm mix performances. That means that it can be compacted and prepared at lower temperature, and this is a good advantage for the contractor that can be a bit more relaxed during the execution phase, but also from an environmental point of view, it has a lot of advantages because we don't need to overheat the aggregates and the binder, but we can keep medium or lower temperature. And the performance of the parking lot that was supposed to be on place for only 1 year have been very good. The parking lots are still there for more than 6 years without any problem, and they were used before and after the project as a storage area for all the construction vehicles. So it has experienced some very heavy and slow traffic on it, and there is no sign of any damage. Thank you for your attention, and if you have any question, feel free to ask me.
Take a couple minutes if you have any question for Stefano. Thank you, Stefano. No questions. I have a quick question for you again, maybe going back. Oh, you have Amir? Go ahead.
If there is no one, so I have to make the question so that to make the meeting active. Actually, one curiosity was about the name that you have given to this binder. Hybrid.
Hybrid.
What do you mean by hybrid then?
Hybrid is because it's a mix of modification. There is both Cramp-Brabber and some other additives. Special additives selected by the company to basically lower the viscosity of the material and to improve a bit the performances. That's why it's a hybrid, because it's not only rubber, but there is also some other modification on it. Okay.
The second question is about, you said that you are shipping this to India and different places and so on. And then you show the table that shows some of the specification, such as penetration, softening point, and other things from Sharp. It's actually a mixture of specifications. Some of these could not be really relevant with the asphalt rubber binders, such as softening point or penetration and so on. Did you do some sort of testing on Sharp 2, Sharp Plus testing on these binders, and do you have some results?
Yeah, I don't have the results here, but yes, we did a bit all the tests. The problem at that time is that there was no specification at all for the material. So we were left basically free to use, to do whatever we wanted with the material. They wanted to use Cramp-Brabber, so we were forced to use rubber, but there were no requirement at all for the test. We run usually all the type of tests on all our bitumen, but in this case I just reported these are some of the common parameters that are required in UAE. That's why only this table.
Okay, so I would suggest that next time you do
We'll
some presentations, I mean, show some master curves of the behavior and so on. Thank you.
Thank you. Any other comments or questions?
Excellent. Thank you. I didn't quite understand how much percentage of this hybrid material you put as a percent of the bitumen.
Crumb rubber was around 15%
Of the bitumen.
of the bitumen weight, and the other additives around 4 to 5%.
Yeah, but that's strange because you only get the PG76 with the 15% crumb rubber. In the wet method, you already in PG, let's say 85, 86, 96.
What was the base binder before 76? What?
It was PG 58,
So that's quite a jump.
and
58 to
Much
76.
with 15% rubber.
but we also have other additives that lower a bit the viscosity of the material, and these can lower a bit the performance grade.
Okay. Thanks.
What's really interesting here is, and we've done something similar, is those mixing and compaction temperatures with the warm mix additives is quite a bit, well, impressive for a crumb rubber mix.
This was the main purpose of this material, because
Yeah.
we cannot, the contractor was really scared. It was their first project with crumb rubber modified bitumen, and the quantities were quite a lot. So they were really scared about the entire workability of the material, from mixing to laying the material at site.
And it can ties in with the overcooking issue that we just mentioned in the previous presentation. So I think this hybrid system is really, one process, successful process to go about. Yeah.
It could be a good solution to introduce crumb rubber modified bitumen in places, like we were saying yesterday, contractors and authorities are quite scared about using new materials. And with this hybrid modification, we have
Got it. Yeah.
we have bought crumb rubber modified material, so something new, but that behave like a normal, at least from the workability point of view, behave like a normal bitumen. So contractors are more willing to give their time and machinery to test this new material.
Thank you, Stefano. One more time, thank you very much. We'll proceed with the third presentation. It's also online. Professor Ahmed Fahim Mahmoud, who is joining us from Khalifa University in the UAE. So I think Fernanda is going to help us here with giving Professor Ahmed the floor. And Professor Ahmed, please introduce yourself and what you are doing in Khalifa University. Feel free to introduce yourself.
Do you have someone else enter the?
There is, Dr. A. Fatim, the one you see?
Yes, that's me.
He's already there.
Yeah, so go ahead and you can share your slides.
Just, I'm trying to share it now. Yeah.
Okay.
No, he's going to share.
He's going to share.
Oh,
Yeah.
okay. No. Okay. So he can share.
Yeah, he's trying to do it.
Now?
Okay.
Okay, which one do you?
We're good to go. I think we have it. We see it, right? Yep, thank you. Go ahead.
Okay. Good morning, everyone. It's very nice to be with you here today. Thank you for the invitation. What we're going to talk about today is trying to look into the feasibility of using rubberized asphalt in the UAE. As you can see from Stefano, he's also in the UAE. We're still taking our first baby steps compared to Qatar, where they are, have covered more ground than us. So it was important as this technology is being considered in the UAE is to conduct some sort of a feasibility to evaluate whether the rubberized asphalt will help, resisting some of the distresses they see in the country. So let me start with my introduction. My name is Ahmed Fahim. So I've been a graduate from the University of Wisconsin under Dr. Hussein Bahia some time ago. That's why I didn't put the year. I've been working in the US until I reached the rank of associate professor at Temple University in Philadelphia. I left there in 2023 and joined Khalifa University, so recently, relatively speaking. However, I'm actually leaving Khalifa University end of the year and to join the American University in Cairo starting January, which I would like to take the opportunity to respond to Dr. Bahia's request for hosting the next MISAT. So I would love to host it at the AUC in Cairo, Egypt. I'm sure we'll be able to do that. They have very nice facilities there. Look forward to work with you, with MISAT on that. My background is being a graduate of Dr. Hussein Bahia. So I'm my technical training is in bituminous materials in general, mixtures mostly, mineral fillers was my PhD topic. But I also branched out a little bit looking at modeling of pavement life cycle, complete life cycle using machine learning and trying to use data-driven analysis in addition to promoting circularity and upcycling. Please join us at the next TRB. We have already papers on these two topics, and I would love to discuss them with you at the next TRB. This is a research work that, or a case study that a student named Mr. Gohar Alam prepared for his PhD thesis, which is coming up recently. This research work started, and I have to credit Dr. Michel Lanotte. He's in Michigan State University now. He was my predecessor at KU. He started some of this work before me, and I took over when I arrived. Quick background, we have, as you can expect, underutilized waste end-of-life tire in the region. So part of, the UAE contributes to that region by about 90% of the end-of-life tires. And that was, in line with the initiatives, sustainability initiatives out of the UAE, very similar initiatives to Qatar, and yet the implementation of rubberized asphalt is still in trial stage. Also, in looking at this topic, while it is taking